radioactivity, radioactive decay, or basically just radioactive decay. What we mean is basically the disintegration or the decay that occurs. In other words, the changes that occurs when an element emits radiation. So for an element to be stable, it has to release, for these elements to be stable, it has to release some radiations. These radiations that are released, once the atom element releases these radiations, it means it wants to be stable. So in wanting to be stable, it will release either the alpha, the beta, or the gamma radiation. Now those changes that occurs when it releases this radiation is what we are calling as the radioactive actually decay. So we are saying this is the changes. This is basically the changes that occurs. The changes that occurs when unstable atom, okay, when an unstable atom, in other words, this unstable atom is considered to be a radioactive element. So whether we say a radioactive, unstable atom or radioactive element releases either alpha particle, okay. The other radiation that can be released is the beta particle or the gamma. So it will continue releasing until it becomes stable. So it continues releasing these radiations until it becomes stable. So first of all, the decay occurs because the atom or the element wants to be stable. So when it wants to be stable, it releases these radiations we are calling as alpha, beta, or gamma rays. Now it will continue releasing those radiations until it becomes stable. Remember, a radioactive atom is basically an unstable atom. Is that okay?
Yes.
Now, let's look at what happens to the atom or the radioactive element when it releases, say, alpha particle, or if it releases beta, or if it releases gamma. What happens to it? So, let's begin by looking at alpha decay. Alpha decay. So by the symbol, we know to say alpha can be represented as that. So alpha decays. Remember, by definition, we defined alpha particle as the one where it releases an helium atom, or in other words, alpha particle is basically equivalent to an helium atom. So the key areas when you are looking at these decays is, first, you need to know what happens to to an atom. Remember, an atom is made up of, suppose this is an atom, remember that this atom, it has A and Z representatives. So now, when you talk of A, we know to say A is basically the mass number, and B and Z is basically the proton number. So when you are looking at each decay, these are areas you have to focus on. These are areas you have to focus on. First of all, you need to know what happens to the mass number when a radioactive element undergoes decay. Also, what happens to the proton number when this element undergoes the decay we are talking about. Remember, X is basically an element. So this element in this case is basically a radioactive element. A radioactive element. So in what we are simply saying is that there are two areas that you focus on when an element undergoes this decay. You need to look at what happens to the mass number and also what happens to the proton number. So if an element undergoes alpha decay, the following changes take place. So if a radioactive element undergoes alpha radiation or alpha decay, the following changes occurs. So now let's look at what happens to the mass and the proton number. So if an element undergoes alpha radiation, number one, the mass number reduces by 4. The mass number reduces by 4. So once it releases one alpha particle, the mass number reduces by 4. Number 2, the proton number reduces by 2. In other words, you are going to subtract a 4 and you're going to subtract a 2 from the proton number. For example, if we look at, we can get any radioactive element like radium. So let's have radium here. So if this is radium, remember it has a 226 and a 88 here as the proton number. So if this radium undergoes alpha, or in other words, it releases alpha, okay, so we are going to indicate it like that, a new atom is formed, a new element. So we don't know what that element is, so we can represent it by letter X. Let's give it X. So what happens? Well, this is an element, the new element that you are going to produce. Now we are saying the mass number should reduce by 4. So if you look at 226, from 226 we need to subtract a 4, because we are saying it will produce the daughter element where the mass number must be reduced by 4. So 226 minus 4, you are going to have this new element with a proton number of 22, and the mass number must reduce by 2, so you are going to have a 86. So this is the new element that you are going to produce, plus. Now remember, we are reducing by 4 the mass number by 4, the proton number by 4. So this is where now that helium element comes in. The element on the periodic table, for example, if it's X, that has 4 on top and 2 on the bottom, this element is basically what? Helium. That's why we say plus the helium nuclide. So you are going to put 4 here and 2. So always when this a radioactive element undergoes alpha radiation, you expect to produce, this is known as the daughter nuclide and a helium nuclide. So this, to get the daughter, the mass number must be reduced by 4 and the proton number must be reduced by 2. So this one, the radium here, it is called the parent. The parent nuclide. And this one here, it is called the daughter. The daughter nuclide. And this one is now the helium nuclide. So the helium nuclide is always released whenever a radiation or the radioactive atom undergoes alpha radiation. Is that fine?
Yes.
Okay. So now, what about in a case where this same one, let's say they say if this actually again it produces an alpha atom particle. So again it means from the daughter you are going to remove 4, the mass number reduced by 4, this other one also reduced by what? Excuse me, by 2. So it can continue disintegrating or decaying, but as long as it is producing the alpha, it always be reducing by 4 and 2, 4 and 2, just like that. Now, what about in a case maybe where we are dealing with or this element, let's say that has the proton number of 241 and the mass number of 94. So if they say this one is undergoing alpha radiation, what do we expect? Remember, you are going to produce the daughter, so the daughter must have this 241 must be reduced by 4. So 241 minus 4, you are going to have what? What are we going to have?
237.
Okay, so we are going to have 237 and the mass number will be 96 plus a helium atom. So now in general, every time you have an alpha decay, if this is an element with A and Z, if this produces alpha, you expect to produce an element. Let me use a different, let's say an element Y that will have A minus 4, and then ZD you reduce by 2 plus an helium atom. So always this is how it disintegrates. Is that okay?
So you can come again on general what?
I'm saying on the general reaction, we are saying if this is an element, the parent one, if this produces the alpha particle, the symbol here is for alpha. If it produces an alpha, the mass number must reduce by 4 while